Okay, let's just dive right into this explainer. Today, we are tackling a massive, honestly hair-pulling frustration for teams building AI coding workflows. If you've been working in this space, you already know the promise. AI coding assistants are supposed to make us incredibly fast. But there is this silent, massive roadblock that almost every single engineering team hits the second they scale past a basic prototype. And it all revolves around how we actually govern the code these AI models are generating.
I mean, think about it. You've got an established set of architectural decisions, ADRs, style guides, team conventions, your internal wikis. And naturally, you want your AI assistant to actually respect them. When you first try to govern AI-generated code, RAG, Retrieval Augmented Generation, feels like the obvious answer, right? Just fetch the relevant docs, inject them into the prompt, and boom, problem solved. Well, actually no. In this explainer, we are going to unpack exactly why RAG spectacularly fails to enforce your decisions and what you actually need to build instead.
So here is our game plan. We'll start with the RAG governance illusion, then look at where vector similarity breaks down and contrast suggestion with deterministic enforcement. From there, we'll map out RAG versus true governance architecture, and finally dive into the structured schema solution. Let's get into it.
Part 1. The RAG governance illusion.
This analogy really perfectly nails the core mismatch we're dealing with. RAG is basically a super helpful librarian. You ask a question, and they scurry off to bring you a huge stack of relevant books. Which is awesome, right? But to protect a codebase, what you actually need is a strict bouncer checking IDs at the door. You don't just want relevant information, you literally need to prevent an AI agent from making a move that violates your service boundaries. Now, to be totally fair to RAG, it is undeniably fantastic for documentation lookup, FAQ support, context injection, things like that. If you ask an AI, hey, how does our auth middleware work, RAG is phenomenal at pulling the right design doc and summarizing it. But here is the massive catch. The common thread across all these use cases is that it only suggests. It enforces absolutely nothing.
Which brings us to Part 2, where vector similarity fails.
So the absolute crux of the issue is that RAG retrieves based on semantic similarity, and that is completely divorced from decision authority. Picture this. You ask your AI assistant which cache library to use. RAG might pull up some random engineer's outdated blog post about Redis right alongside your strict authoritative ADR mandating the use of Valkey. It pulls both because, mathematically speaking, they're both about caching. It has zero mechanism to say, hey, this ADR is the law, and that blog post is just noise. It's absurd to expect the AI to just magically guess which one is official. RAG ranks by similarity, but true governance requires ranking by authority. They are entirely different dimensions. And as your rulebook scales up to hundreds of documents, embedding-based retrieval just outright falls apart. Why? Because architectural decisions for developers come with incredibly precise scope signals, like specific file patterns or service boundaries. Vector math simply does not compute that a fuzzy natural language embedding for use dependency injection is strictly bound to a hard file pattern like services/payment/handler.py. If you want scope-aware retrieval, you need structured matching, not fuzzy vector math.
Moving on to Part 3, Suggestion versus Deterministic Enforcement.
Let's say you've got an organization-wide rule from 2022. Use PostgreSQL for all relational storage. But wait, you also have a specific project-level decision from 2024 saying, for this one specific microservice, use SQLite for simplicity. So, which one wins? RAG cannot handle conflicts like this. It just yanks both documents, chucks contradictory rules into the prompt, and leaves the AI to guess. And usually, the model just picks whichever text sounded more convincing. That is completely non-deterministic and, quite frankly, totally ungovernable.
And that is exactly why we need a massive paradigm shift. True architectural governance means moving away from diagnosing the problem with passive context injection. We need a precedence-aware layer that deterministically inspects outputs to block or flag violations. We need a system that takes those retrieved decisions, resolves the conflicts deterministically, and produces a single authoritative answer before bad code ever gets committed.
Let's look at how this breaks down architecturally. In Part 4, RAG versus governance architecture.
Putting these two approaches side by side proves they are fundamentally incompatible. On one hand, RAG retrieves based on embeddings, leaves conflict resolution completely up to the AI's whims, and relies on free-form text. But on the other hand, a true governance layer retrieves by strict scope and keywords, uses a deterministic precedence engine to resolve conflicts, and is built on structured, typed fields. You literally cannot turn a suggestion system into an enforcement system just by tweaking your vector database. They are completely different beasts.
So, how do we actually fix this? Part 5, the structured schema solution.
To stop confusing the AI with free-form text, your decisions have to use structured, typed fields. We are talking explicit fields for the scope of the rule, the underlying rationale, its current status, what older rules it supersedes, and the hard constraint itself. When you structure it this way, violations can be detected consistently by code, not just guessed at by a language model.
Here's what this template actually looks like in the real world. Notice how explicitly defining typed fields, like targeting everything in the services payments directory for the scope and mandating PostgreSQL with SQAlchemy for the constraint, allows the system to definitively intercept the rule. Because we aren't just parsing a paragraph of text, a software engine can actually read that precedence level, see that it supersedes an older ADR, and execute a hard deterministic check.
Let's walk through how this builds into an actual workflow. Step 1, the AI model attempts to write to a scoped file. Step 2, thanks to those typed fields, the decision record fires perfectly based on the scope pattern, bypassing fuzzy semantic similarity entirely. Step 3, if multiple rules pop up, the precedence engine mechanically resolves the conflict. And finally, Step 4, our enforcement layer, the bouncer, steps in. It outright blocks the write if the AI tries to sneak SQLite past it. Boom, bad code stopped before it ever reaches human review.
So take a really hard look at your architecture and ask yourself, is your AI workflow built on suggestions or is it powered by enforcement? RAG is brilliant for giving an AI background knowledge for sure, but the second you need a guarantee, the second a bad architectural move could tank your service, you need an enforcement architecture. Are you just handing your AI a stack of suggestions and crossing your fingers? Or are you actually governing your codebase? Definitely something to chew on before your next code review. Thanks for joining me on this explainer, and I'll catch you in the next one.